Hi everyone, welcome to our Aquarium Online Academy. My name is Jen, and today we are going to be talking about, can you guess what it is? Threw you off with the jellies, didn't I? We are going to be talking about octopus today, so it's going to be very exciting if you want to move like an octopus along with me. Right? So these animals are absolutely incredible, and I'm really excited to be able to share some of our octopus footage and for us to be able to explore octopuses together. So I am not alone in the studio. I also have James, who's going to be showing us some great octopus footage right behind me, and then we also have Talia in the studio too, that's helping out with relaying your questions and comments to us here within. So if you do have a question or something that you're interested in sharing, like a really cool observation, go on ahead and send it right down here to 562-286-1838. And of course, texting rates do apply. So if you are a younger viewer, please make sure that you get adult permission first. If you happen to be watching this outside of Thursday between 11 and 11:30 a.m., please go on ahead and email us down below at live@lbaop.org. All right, so we're going to go on ahead and start with this lovely right back here. I'm going to step out of the screen for a second, and we're going to get a chance to look at our octopus. So this is our giant Pacific octopus within our Northern Pacific Gallery here at the aquarium. What do you notice about our octopus? Is there anything that really stands out? I notice its flexible arms, right? That's moving all around. And on each one of these arms, see lots of those suction cups, right? We're seeing all of them kind of move around as our octopus moves. Oh, pretty cool. We're able to count how many arms our octopus has? Generally, it has 8. I say generally because maybe out in the wild it went into an epic battle and maybe it lost an arm, or so it might have 7. So octopus generally have 8 arms right here. Now, if we notice, right, how is it using those suction cups? What do you see? Oh, here's a great close-up. If we go on ahead and we look at our octopus's suction cups, right, we can see it's taking a stick, and then it's just kind of off, and then another suction cup goes on, and multiples of them can be working at a time. Now, what's really incredible about these giant Pacific octopus arms is they can have up to 250 suction cups per arm. Now, if you want a good math workout, you can multiply that by 8, and you can get a much larger number than 250, right? And so with that, these animals have to have a special way, right, a special adaptation, a special feature that helps them to be able to control all of those suction cups and all 8 of those arms. Now, lucky for them, these animals have a way to be able to do that. They have about 9-ish brains. Yep, that's right. We think we're smart, right? These octopus have several more than we do. I guess that would be 8 more than we do since they have about 9 brains. And so each smaller, simpler brain controls each one of the arms. So each one kind of acts independently of each other. And then, of course, there's the main brain, a little bit behind the eyes there, that helps kind of be the overall controller of the function of the octopus itself. Now, don't worry. The small arm brain and the big brain, they don't ever argue. They're never like, I want to go over here. And big brain's like, no, you will listen. And then little brain can be like, no, I will not. I want to go over here and explore. They don't ever have those kinds of problems, at least that we know of. I mean, scientists are still exploring. But for the most part, these animals here have those 8 individual smaller brains to be able to explore their area. Now, what's really cool about as they get a chance to explore is that those suction cups can taste. Yep, just like how I might be tasting my granola bar that I just had for a snack, right? These animals can taste as they move along. So maybe there's a little whiff of underwater pizza nearby. No, probably like a shrimp, or maybe a piece of squid, Or maybe, oh yeah, I think Lorelei, this might be answering your question, right? What do they eat? So it depends on the octopus, as all of them are different sizes and live in different areas. But they might eat some fish. Crabs might be a really good food for them. Anything that might be kind of crunchy. Now, we do have one video that is I can use my words today. That is an octopus eating a crab. Now, we mentioned our octopus are really smart, right? So smart that they have those 9 brains. And so we have our octopus video here, and its food is actually on the boat. So octopus are very smart, and they are able to solve puzzles and try to find their food in very unique situations, much like this boat here. So what we're doing is we're going to watch our octopus as it calmly and gets interested in what's happening right here. Now, our aquarist went ahead and took her hands and put the crab inside of that boat that we see right there. And of course, she then put that boat into the water, meaning that those little crabby smells are now on the boat and a little bit in the water, which makes our octopus here very excited for a tasty treat. And you can see how cautious our octopus is, right? Our octopus is checking it out. It's very curious. Now, all of those tentacles are like, oh, I think there's a crabby treat here. And it's getting quite excited, as you got to see it color change a little bit ago. And it's tasting all around, and it's like, I'm getting closer. And how? Crab snack, right? Now, it's trying to figure out what's food and what isn't. And you can see how excited it is, right? Look at all those fun colors. And look, even its skin is really bumpy, right? And then, look, there's the boat. Because the boat's not food, right? But that crab was so delicious. And so now our friend here is going to take her crab, because she likes to take her food to go. And so she's going back on in, or he's going back on in, to be able to eat in peace, right? Much like myself, I feel like I kind of take my pizza and then I go into a spot and and I eat my pizza. All right, so hopefully, Lorelei, that answered your question. I know Bastian is asking, why do they have suction cups? Right? Because they do have a lot of them. Now, Bastian, I don't know if you're just tuning in right now, but earlier we talked a little bit about how they can move. And so let's review that real quick so we can go on ahead and see how all these suction cups are moving around and helping our octopus to stick, helps our octopus to explore, and even taste for any kind of food that might be nearby. And so these suction cups do a lot of different things. Now, part of Lorelei's question was, how do they eat, right? And so they use those suction cups not only to stick to our exhibit right here, but also maybe to rocks or to stick onto that tasty crab to bring it into its mouth, which is in the very, very middle between all of those 8 arms. Now, they have a mouth called a beak. And when you think about a beak, what do you kind of picture? Kind of like a bird beak, right? And so it kind of looks like that. Now, I have a cousin of a octopus. I have a squid beak that I'd like to share with all of you. So I'm going to grab that real quick. And you can see it right here. And I actually might put it underneath the document camera so you can get a better view real quick. But this is about the general size of our squid beak. So let's go on ahead and look at it a little closer underneath our other camera. All right, so I'm going to turn on the lights. Maybe. There we go. All right, so hello. I am right here. So you can also see the size of the beak in relation to my hand size right here. And this beak looks like this. So here you could see, right, it doesn't really have, and I'll zoom in a little bit. It's actually 2 pieces that we have right here that kind of hook into one another. And if I zoom in, you can kind of get a better view of this beak right here. Right, so I'm going to stick it on its side. Now, I don't think I see any serrations, meaning that on the edge, it doesn't kind of look like a knife that you might eat with all those little teeny tiny teeth. Instead, these beaks have kind of like a very pointy, pokey end up top right here, right? And it's curved, and it's actually very, very solid. So it's not flimsy, it's not gonna bend. Trying to bend it, but I can't. So this is a very, very good beak that it uses to be able to eat. But you can see how it's kind of flexible too, which is kind of cool. It can open and close. All right, so that beak right there helps them to maybe pierce some things that might be crunchy, like a crab or a shrimp, anything like that that may be hard. It can get into the gushy, mushy parts that are in that middle, so it can suck out all of those deliciousness. A lot of times they'll also eat maybe sometimes some fish. Some of them will actually eat some other kind of snails too, believe it or not. So it really depends on the actual octopus itself. Ah, Bastion's asking, why are octopuses different sizes? Yeah, right? So we have all sorts. Like the biggest that we have is our giant Pacific octopus. That one can get anywhere if we measured it from tentacle to or arm to arm, right? And we put it out really wide, it can be anywhere between maybe 10 to 16 feet. Yeah, that's huge, right? That would almost be like 3 of me. 2 to 3 of me, depending upon how tall I feel for the day, right? And so it can be really big. Now, the tiniest little eensy beensy octopus is actually about the size of my fingertip. And that's let's see if I can get this right, the pygmy star sucker octopus, something along those lines. So with this octopus right here, it's only about the size of my pinky. It's really tiny. I think it's a star sucker pygmy octopus. There we go. I got it right this time. So it's about the size of a dime. It's really small, which means it probably eats really small food too. So Bastion, not only do the sizes, help them to figure out what size food they eat, but they also live in very different habitats or very different environments. And those environments, or they need to be able to kind of change to be able to live successfully in those environments, right? They have to have those special adaptations. And sometimes size is one way that you can, kind of adapt to that environment. Now, octopus, though they are different sizes, can also be really, really big. They can inflate themselves and stick out all of their arms out, or they can be really small, like our friend over here. This is also a giant Pacific octopus, if I'm not mistaken. But with this one right here, doesn't it look a lot smaller? That's because these animals, the only hard part that they have in their body is that beak that we saw earlier. Meaning that every other part on them is very squishy. So squishy that they can basically move themselves into any little crack or crevice. Here's a nice example here, where this octopus I think might be a little afraid. You can see it ink right there. But look at it going into that little crack or crevice. It's just squeezing itself into a very small area. And look, it's trying to defend itself right there. More of that cloudy ink right there to maybe scare away a potential predator. And then it's just really kind of squishing its way on into something really tiny right there. All right. Now, these octopus live in a wide range of habitats. Some of them, well, you can find them in tide pools off of California, meaning that if you go during low tide, right, where the rocky beach meets the ocean water, there are these pools that are left behind by waves. And so there are some octopus that will be in those tide pools. Sometimes you'll find a red octopus in there. And so that's kind of cool to be able to see. Another local octopus that we have off of our coast is the two-spot octopus, which is right back here, known for its 2 spots, of course. We have 1 spot here, and then we have the exact same spot on the opposite side. And so these animals can get up to like 3 feet in length. So, maybe about like the size or so. Or if you put out your hands, right, that's about the size of the octopus if it went ahead and it took out its arms and it went really a big stretch. And so these octopus can live within the shallow parts of our ocean, which is really neat. The red octopus can actually live all the way down to 600 feet or so, but our two-spot, I think, doesn't really go down as deep. So, but those animals are a little bit smaller as they can sit into cracks and crevices as they are really shy animals overall. All right. But oh, more questions. This is great. Thanks, friends, for asking. Jason and Chase are asking, why do they camouflage themselves? That is a good question. Let's see if James can bring up a video and maybe we can answer that together. I'll move off screen real quick. So here we have an octopus. It's really red right now, but whoa! Did you see that? It's so cool. Where did the octopus go? Oh, there it is. But man, isn't that incredible? These animals can not only change the texture, it goes from like red to all these colors, but also went from very smooth skin to super bumpy skin. Wow. So why do you think they might want to blend in with their surroundings? Well, if you're thinking maybe to hide from a predator, for sure, right? And if it's to hide to maybe get a jump start on its food, absolutely, right? So some of these animals will kind of sit and wait, and they'll look just like that. And then when a tasty food comes around, maybe that shrimp or crab or squid, whatever it may be, or maybe fish, they'll go on ahead and come out. They go, ha ha! And they'll grab it real quick, and they'll be able to eat that tasty treat. So those are just a few reasons to why they choose to camouflage or blend in with their surroundings. And Bastion is asking, why eat different animals? Well, that's a really good question. Why do we eat different foods? Well, not only for the taste, right? Maybe sometimes it's fun to eat something different, but also because it offers different nutritional value, right? We get different vitamins from eating different foods. And so same thing for these animals. They get different vitamins, and it helps them to feel healthy if they're eating more than just one food for their entire lives. Also, depending upon where these animals live, they may have different kinds of foods that are available. Like for instance, some of our deep sea animals, like our deep sea octopus, they might not have the same kind of foods available as one that lives in a tide pool, one that lives up at the very surface of the water. And so because they live in different places, they eat different foods. And that helps out those environments and those animals. But it also provides them with lots of different vitamins to keep them happy and healthy, just like us. All right, so let's go on ahead though and really kind of get a chance to look at our octopus right here, because we've talked a lot so far about its arms, right, and all of those suction cups, how they use those suction cups to be able to smell, how they use those brains to be able to move all those different arms around. Now they're able to eat by using that large beak to be able to crush foods, right? Now, what's kind of crazy, though, is that this part right here where the eyes are, well, guess what? The brain is just right above it. Yep. Isn't that cool? Now, not only is there brain up here, but do you see the rest of this? That's where all the other body organs are. So if you're thinking stomach, yep, right in there. Intestines, yep, right in there. Gills, like I think Bastion was asking, yep, right inside there too. So they actually breathe a little bit behind their head. This is what we call the mantle, which is basically like the rest of their body, right? And so if we think about where they have to use the restroom, right up there too. As a matter of fact, for breathing and restroom use, it is actually out of this area right here. This is called the siphon. And maybe we can check out a really cool video. James read my mind, right? So let's go on ahead and see how it's all working. What do you notice? Well, I definitely see the siphon right here, opening and closing. But I also see a little bit past the siphon. This is the mantle opening. So that's that major body that's opening right there. And so it's sucking in water and it's moving it through the gills. And when they want to get rid of that water, it goes out the mantle. Do you see how the timing is different? This one goes, right? So not that they snore. Maybe they do. I don't know. I've never held an underwater microphone to an octopus before. But water goes, in, and then it goes out, right? And so what's really cool is that those gills are constantly getting all of that fresh water in. And then, that water or maybe some, octopus excretion. So maybe some of the octopus pee would then go on ahead and go out that siphon right there. So it's multi-purpose. Isn't that convenient? I think so too. All right. And then Bastion is also, Allie is asking, if an octopus lost their arm, can they regrow it? Now, they might be able to grow back like a little bit to kind of cover part of their arm that may have been, like cut off for whatever reason, but they cannot actually grow back the entire arm. So that's a great question, but they cannot grow back their entire arm itself. Yep. And Bastion is asking, are they mammals, right? So if we go back to the beginning, we saw jellies, right? We saw our beautiful jelly cam, and I said that we're talking about octopus. Now, what do you think might be a common feature between the two? Well, they are both squishy. They are both kind of slimy. But the main thing is that they don't have a backbone like we do, right? There are no hard parts inside of our jelly right here. And if you remember our octopus, we only said that beak was the hard part. So for us, we have lots of hard parts. But if we talk about the main one, we have our backbone that runs all the way back. And you can touch it down here next to your spine, or maybe a little bit behind your neck, that bumpy part. That is your backbone. And so mammals have a backbone, but those that don't have a backbone are called invertebrates. We are vertebrates. We have that vertebrae that makes up our backbone. Vertebrae are all the little bone pieces put together to make up our backbone. These animals don't have a vertebrae. They don't have any bones, really, so they are invertebrates. Now, mammals are a type of vertebrate. Mammals have that backbone. The mammals have some other characteristics too. All right, so we know that they have a backbone. Can you think of any other mammal characteristics? If you need inspiration, we are actually mammals. So, let's see. And James, he's actually a mammal too. So, let's see. Breathe air. Yep, check. Let's see. Has hair. Gives live birth. So we don't come out as eggs, right? We come out as miniature humans. And then let's see, we drink milk, right? So when we're babies and maybe beyond, right? We drink milk, but mainly when we are babies. And then we also have warm blood. So our temperature always is about the same, right? We don't have to be like a lizard and sun ourselves to get warm on a rock to help us move a little faster. Now, we might just lay on a rock anyways, because who doesn't love a good warm rock? I sure do. But for the most part, we don't need to lay on a warm rock or warm up to be able to get our blood moving and going, right? If we're ever cold, we can just wear a sweater and our body will warm back up to that temperature. If we put a sweater on a lizard, that'd be real cute. But it wouldn't warm itself up. Like, it wouldn't be like, oh, why, thank you, Jen, for the sweater, right? And then we can make it a little pants and a little hat and scarf, and it still wouldn't be fully warm, right? We'd have to put it out in the sun to be able for it to warm up. So sweaters don't really work too well on lizards. Fun fact for today. All right, friends. We did get some other questions. Kevin is asking, how do they change color, right? Because we did talk about camouflage and the way that they are able to. Let's see if we can look at some of those color-changing cells. Because if we look at their skin, they have something called chromatophores. And squid have it too, so do cuttlefish. And these are color-changing cells. And what they do is they open and they close. And depending upon how they open or close, it changes the colors of our octopus itself. So it's really cool that they can do that. If they stretch out that chromatophore really like a lot, then they turn lighter. If they choose to squeeze that chromatophore or that circle down, then it gets darker, right? And so that's the way that they can change that cell. It's pretty cool. Now, they even have muscles inside of their tissue that helps them to become bumpy or smooth. And so that's another cool adaptation or feature that these octopus have, is that they can change their skin, right? Now, best I can do is maybe get goosebumps, and then I may be feeling a little pokey. But aside from that, I don't have those same color or so those same kind of like muscles or those same parts inside of our skin that these octopus do. Awesome. So here are these chromatophores. So you can see there's different kinds, and some of them, like this one, you can see it's slowly getting darker as it squeezes down. But you can also see these darker ones and how they flash and they move, right? And so that's the chromatophores up close. All right. And then Allie is asking, how do you tell if an octopus is male or female? You didn't see those eyelashes? I'm just kidding. No eyelashes on these octopuses because they don't have to worry about dust or dirt like we do, which is the function of our eyelashes. What these animals do is if we look, we have all of these arms, right? And we can see suction cups going all the way down, right? And so for an octopus, I think it's the third arm on the right, there's something called a hectocotylus. And that is basically an area where the male can deliver its packet over into the female. And then the female can use that packet to fertilize her eggs. And so you'll see on the, I think it's is it the male, James, that it lacks the suction cups on the end? Or is it the female? I always get those mixed up. I think it's the male too. So we're saying male. Basically, it loses or doesn't have any of those little suction cups at the very end. And so that way it can kind of deliver that sperm packet over to the female. And then she can sprinkle those over her eggs and then go into maybe like a cove to be able to fertilize those eggs and protect them and keep them oxygen rich and away from predators. All right, so May is asking how octopuses make itself bumpy, like the rocks. Yeah, so it looks like confirmation on the... It is the male. Excellent, thank you. So it is the male that's kind of missing the end. And so this one looks like it's kind of hard to say because it looks like it's like, yeah, check me out, So it's hard to see which one's the third one from the right on this one. But usually, maybe if you see an octopus fully out, you might be able to see some of those suction cups missing from the very tips of that arm. But an octopus can make itself bumpy by having those little muscles inside of its skin. It's able to be super smooth, or it's able to really kind of make it super bumpy and have some really cool shapes to it. Different octopus have different abilities, and some of them, here we go. Here's a nice video, and we'll get a chance to see it kind of go from really super smooth right now to super bumpy. That's so cool. So it's all those little muscles inside of its skin. We as humans, we don't have those muscles, but these octopus, that's a really cool thing that they do have. Now, different octopus have different abilities, right? So our giant Pacific octopus right here can get really super bumpy. Check out those bumps. Pretty epic. Yeah, right? Now, some octopus can have different sort of behaviors, and they can use their type of skin to be able to do different things. So some of them are really extra good at camouflaging. Others might mimic different behaviors, like a mimic octopus. They might change their color and shape and texture to be able to, and swim maybe, even to look like a different animal. So that's just another way that octopus can be different depending upon the environment that they live in. So that is really cool to be able to see. All right, friends. My goodness, look at the time. It is already 11:30. I just want to say thank you all for joining us today. We talked a lot about different octopus adaptations, from the way that they use their different arms and all those suction cups, to how they eat with their mouth, to how they breathe and poop, or I guess more like pee, and then how they have all of the rest of their body organs inside of their body right here. And a little bit more about their behavior and how they're able to change colors and textures. So thank you all for participating today. If you do have any further questions, you're more than welcome to email us at live@lbaop.org. We'd be happy to answer any of those octopus-related questions that you might have. Now, we do have more programs coming on up. So if you're like, man, I really want to see another program with James, and, learning about fish wasn't enough, I want more, not to worry. We have our wetlands class that are coming up. I'm really excited about wetlands. Hopefully you are too, because we're going to get a chance to learn a little bit about that really cool ecosystem. And then if you're like, I want more fish, I just want to continue learning, we have a fish dissection that's going to be happening later on. We will be looking inside of that fish. So just to let you know, if you're kind of squeamish about that sort of thing, or if you're not, just kind of a heads up there. All right, thanks everyone. We hope to see you later on today on another Aquarium Online Academy. Once again, my name is Jen, and have a great rest of your day.